So we started solving equations, trig equations yesterday. And now we're looking at, so all of the ones yesterday had just a single angle, so theta or x. We didn't have any stretches done to those trig functions or any translations. So we strictly had to isolate the trig ratio and then solve for the angle. Okay, now we might have some stretches being done and some translations to the angle. So we got to work backwards, right? It's almost just like any kind of equation we started in Math 8 and 9. You work backwards order of operations till you get back down to x. So we're going to just start with the first one. No, this is regular as well. It won't be much regular, but I'm pretty sure it's is it in the textbook? I don't know. Oh, actually, I guess it is IB now. There are some questions in the textbook, but we did put IB, so I guess you're not going to be tested on the diploma on it. Right? Or the Q2. Okay, so first one here, we want to isolate the trig ratio first, unless it's squared, right? Then maybe, or there's more than one term with the trig ratio. Remember, then you want one side to be 0 and factor. Most of these, there are a few you can see here that you'll have to get on one side, but most of them you probably won't have to factor, just because you want to test on the stretching and translations part of it. In any case, we'll get sine of 2 theta by itself. Okay, so just divide by 2. You can put brackets around 2 theta. If it's something like that, it's understood to be the whole angle, so you can have brackets or not. But if you have a subtraction there, you really do need to have the brackets, especially if it's in radians, right? So from there, what you could think about is, let's say, and you don't have to write this down because I'm not going to do this, really follow through on it, but I'm just going to talk about it. We could let theta equals 2 theta. Okay, then what would we be solving? We'd be solving sine of theta equals negative 1/2. Well, you've been doing that for a while now, right? So doing this, sine is negative and the third and fourth. Negative 1/2 would be there and there. In this case, it says in degrees. So the reference angle would be 30 degrees. So your angles would be 210 and 330, okay, for beta. Remember, though, beta is 2 theta. So what would you do to those angles to get what theta is?
Divided by 2.
Divided by 2. Okay, so you can do that if you really need to, but let's just think about this as that bracket, whatever that is. So 2 theta equals what? We said 210, right? Sine of 210 gives you negative 1/2. Sine of 330 degrees gives you negative 1/2. Okay, now maybe you stop there because that's within the domain given. But what happens, there are more, right? What happens when I divide by 2? I get what, 105, 150, 165, and I will end up missing some. Okay. So remember, if you do a horizontal stretch by a factor of 1/2, then you're going to get twice as many cycles in 360 degrees, or 2 pi, right? So you're going to get twice as many in that. So you want to do another round here, okay, another rotation. So 210 plus 360 is what? 570. 330 plus 360 is 690. Now divide those by 2. We'll get this piece. Okay. So then divide this by 2, that's 250, 285. And 690 divided by 2 is 345. Okay? Those all are contained in here. So you could, what you can do is think about that stretching, or take a look at what your argument is. This is for theta. If I multiply everything by 2 here, I get 0, 2 theta, it's a 2 there, and 720. So basically, if I have 2 theta, which are those ones, I would want to get these angles all to be between 0 and 720. Okay. So that's maybe what you want to think about. Take a look at the question. What angles are, what domain are you asked for your solutions? Obviously, if it's all real numbers, you're going to have to do a general statement anyway. Okay? But that will help you decide what to start with, right? So we want all the angles between 0 and 720, so I have to keep going there. Okay. So that's number 1. Which is the next one I wanted to do? I want to do number 3, because number 3 is a half theta. Okay. So you want to, yeah?
Sorry, is it allowed to equal theta in this degree, or
Oh, just okay, so we're going to do number 3 together. One side's already 0, but it's just a single tan ratio, so I want to isolate the tan ratio. If I bring it over, then it'll be 1 equals, or I'll show it on the left. Okay. So now if I think about that domain, so 0 less than or equal to theta, less than or equal to 360. If I multiply everything by a half, I would have 0 less than or equal to 1/2 theta, less than 180. Okay? So that means I just need to find the angles between 0 and 180 to start. And then my final theta, always go back and check. Okay? So here, that means 1/2 theta equals, so tan has to equal 1, positive, so that's the first and third. And we're still in degrees. So remember the reference is 45. So that's going to be 45 degrees. Okay, then the next one here would be 225. We'll take a look. That's beyond this. So I don't even have to list it. Okay, then theta, I would multiply by 2, and that's done. Only one solution for that particular domain. You might end up doing a few more. Maybe you did 225, like you did 2, a complete rotation. Then you multiplied by 2, you would get 90 and 450. But then you go back, that's not what it asked for, right? So 450 is not in that domain it's asked for. So final statement would just be this. Okay. So that's 3. Then we're going to do 4 together. Because this one has 2 terms with cotan. Should I divide by cotan?
No.
No. not divide by anything with a variable, if at all possible. So I'm going to bring everything to one side. So that the other side is 0. Okay. And factor. Now these ones I'm doing this method where I'm keeping that argument. I'm using my trig ratios. Obviously, we have learned some identities for sine of 2 theta. Cosecant of 2 theta would be 1 over sine of 2 theta, right? So you can use identities, and that's, I think that's listed for 3 more. Learned it, right? So you can do that, but today I'm not going to. I'm just going to solve it with whatever transformation or stretch has been done to the argument. Okay. So now I've got 2 factors. So cotan of 2 theta has to equal 0. Cotan of 2 theta equals 1. Those are 2 statements that I got to solve, right? Each factor equal to 0, just like if you had a polynomial equation. Now, I don't like dealing with cotan that much. I prefer to deal with tan. So tan of 2 theta would be undefined, right? If cotan is 0, that means tan would be undefined, right? 0 would be in the denominator. And so I remember that tan is undefined at 90 and 270 for dealing in degrees, right? That's just how I think about it. Here, if I take the reciprocal, tan of 2 theta, well, the reciprocal of 1 is 1. These aren't restrictions. These are, we're actually solving, right? So here, when, as I just said, tan is undefined at 90 degrees, 270. Now, these are 2 theta. So remember, 0 degrees now, less than or equal to 2 theta, less than 720. That's when I change my given domain, right? Because we're still in the first part here, yeah. Okay. So I need to list some more here. So these, 90, 270. The next rotation, 360 plus 90 is what, 450? 270 plus 360 is 630.
3635. Oh,
630.
I was like, what is 360?
I was just doing my head. Okay, then I divide by 2. Okay, so that's for this part. Now, for this, tan of 2 theta equals 1. So tan is positive in the first and third. 1, remember, is the reference angle of 45 degrees. Okay. So 2 theta equals 45 degrees 225, add 360, 405, add 360, 585. Divide by 2. So this goes here, this. Okay, so there are 8 angles that satisfy this. So in your final statement, I would put them in order.
That's a lot of solutions.
A lot of solutions. There. Yes.
I mean,
Always have to have your final solutions. Whether you put it in squiggly brackets or not.
you could also just kind of like circle, like you could just circle all of the theta.
Want a final statement. Teacher next year is going to want a final statement.
Isn't that just you?
Next semester.
Isn't that also just you?
The students is, well, it depends. The students are Mr. Metallic next semester.
Oh, you don't teach 31 of their intro?
I do, but I am not this year.
Oh yeah, you're the only one. You've done it the most.
Okay, so this equation does have cotan in it, right? So remember we talked about restrictions? So think about whether there will be restrictions or not. There's nothing in its denominator, but cotan can't be undefined, right? So think about, is that going to come into play? So for restrictions, cotan of 2 theta cannot be undefined. So that means tan of 2 theta cannot be 0. Okay? And those would give our restrictions. Well, when we solved this, we had tan of 2 theta equaling undefined. So those are not going to overlap at all. Right? Most of these aren't. The exceptions are really, if you think back to rationals, what else do you, or solving radical equations. Whenever you may have squared both sides in a radical equation, or multiplied through by something with x in it, with a variable, it may introduce some extraneous solutions. But we haven't done anything to this. We've actually got it down simpler, right? So most of the time, it's not going to come into play. But it's a good idea to check. So from here, we know, like even if you just put this on a test, these you could say here, restrictions will not, or you could say solutions are not any of the restrictions.
Yeah, you only, because when you're solving it, you kind of have to, you can't really solve it if you have like restricted values in it, because you're not going to get them. Unless you use identities to change remember what sine is 0. You're not going to have values for cos of 0.
But it's more in the other ones there, like maybe there's something where it's not another value.
Yeah, sure.
Kind of tan minus 1 or something.
Oh, yeah.
Okay? Okay, quiet please. Okay, so we've done 3 in that. Oh, actually, I want to do the 5th one in that section because that has a translation. Okay? So number 5 is 2 cos of theta minus 45 plus 3 equals 4. So the ones that we did do are stretches. Now this has a translation, not a stretch. Same process, isolate cos. Okay, just like we did with that original domain, in the previous ones we multiplied it by 2, or we divided it, multiplied by half, but that we had a stretch. Same thing here. So we start with, that's what's given in our question. So now I want to think about what I would do to get theta minus 45 in here. I would subtract. So I want to subtract 45 degrees from every part of that. What's that? 15? Okay. So basically that tells me when I find these angles, for theta minus 45, I want to find all the angles between negative 45 and 315. Okay? Because there might be, because remember for a translation, for this, in order to isolate theta, I'm going to have to add 45 degrees to whatever my angles are. So maybe if this is negative and I add 45, say it's negative 20 and I add 45, I would end up being in this domain. But I may have forgotten about it because it's negative. So doing this helps a lot, I feel, so that you know that you don't miss anything. Okay, so cos is a half. Cos is positive in the first, then the fourth. Cos is a half, that's a reference angle. We're still in degrees of 60 degrees. Okay. So theta minus 45 degrees will be 60. Okay. Now, if I think about negative 45, that's down here. Negative 60 is too small, so it's actually not going to be a problem in this one. My first will be 60. My next would be 300, which falls in there. And that's it. So then I want to add 45 to both sides. So that's going to be 105 and 345. Oh.
I actually did have a quick question.
Yeah.
Well, like for example, when you're writing the equation of a graph, where do you put the degrees? Do you put it on the outside of the brackets? Like,
No, you put it with, if there's a translation, you put it with the translation. Otherwise, you don't put it anywhere because that variable.
Okay. I've seen these weird versions of it where it's like, there's like brackets and then the degree symbol outside of it.
Yeah.
I mean, usually you guys do radians now, because like, your notes. We're not notes now.
Okay, so that's the translation. Goes back to equations from junior high. Theta minus 45 equals 60. You add 45 to both sides. Nothing different than that. Okay, isolating the variable. Okay, we are going to do you want me to we're going to go to question 10. Okay, so in this one, solving for cos theta between 0 and 5, so that means we have to answer in radians. Obviously, this is a giveaway. There's no degree symbol there, so that's in radians. Okay, so you want to get cos by itself, so you're going to have to take the square root of both sides. Okay, so now this 0 to 2 pi. Here we want that to be theta plus pi over 3 in there. So we have to add pi over 3 to 2 pi. So that's going to be what? 6 pi over 3 plus pi over 3, 7 pi over 3. And then, okay, so that's, if you want to make sure you get all the angles that you need. So, cos is positive and negative, and it's positive and negative 1, so it's actually not, it's going to be a quadrantal angle, right? So, positive 1 there, negative 1 there.
It can't be.
Right, with the left. But we're going to add pi over 3, so it's, I think there's 2. Okay? So, question? Yeah.
Like, why is the domain if the theta plus 3 is it's like, why is the domain it's like bigger than pi over 3 and smaller than pi over 3?
7 pi over 3.
Oh.
I just added pi over 3, right?
So let's put pi over 3.
Oh no, 7 pi over 3. Okay, so when do we get positive 1, okay, and negative 1? So 0.
That's not.
Oh yeah, sorry, 0, so you don't have to include 0, right? Pi and 2 pi.
And 2 pi can't be others. Oh, yes, it can. Oh, that's why I put it in.
Okay, so pi and 2 pi, because 0 isn't in this new domain. If you got 0 to start, you might list a whole bunch, then subtract pi over 3 from all of them, and then check which ones fall in. But if you do this first, then it limits it for you so that you'll get all of them without checking. Up to you how you do it. Okay, so now we want to subtract pi over 3 from both sides. So it's just a linear equation that you're solving. Right, from both sides. So theta, so 3, that's going to be 2 pi over 3. 6 pi minus 1 is 5 pi over 3.
You won't be like solve for theta where zero, like theta between 0 and 83.
Okay, what if though I ask for, so the next section is asking for general solutions. Why don't we do the general solution for this one, folks? Hard for people to concentrate. They're chatting away. Okay, this section of questions, you didn't have to do general solution, but let's do it. Let's see what it is. Okay, so in this case, you may want to do some more to see a pattern. We are dealing with coast that hasn't been stretched. Okay, so that means the period will be what for coast? I need more than just one person. What's the period for coast?
2 pi.
You said 5.
2 pi.
Oh,
Right? So, in this case, all we would have to do then is theta equals 2 pi over 3. If we were to find more, remember, this would then be 3 pi. You should actually check because this was a plus or minus. So we can then maybe simplify this. 3 pi, I'll do it now. So 3 pi, that would end up being 9 minus 1 is 8 pi over 3. Yeah, so we can simplify this. The next one would be 4 pi, which would be 12 minus 1 is 11 pi over 3. Okay? Can you stop talking for a second, please? Okay, so, Gavin, shush. So here, if we had to do a general solution, you may, this is a general solution. But this can be simplified. So remember how I talked about, if it's a multiple choice type question, it might not be given like this, right? It may be simplified even further because this had a plus or minus. It wasn't just cos of theta plus pi over 3 equals 1. Okay, it was plus or minus. So take a look. Here we've got, I extended to check it out. I extended my list of possible angles. Then I subtracted pi over 3. And you'll notice that, yeah, this, we can keep adding 2 pi, multiples of 2 pi, but this to here is adding 3 pi over 3. This to here is adding 3 pi over 3. This to here is adding 3 pi over 3. So we can simplify this. 2 pi over 3 plus n pi. This is the simplest form. Yeah, like I'm not going to mark you wrong if you have this, but just be aware on a multiple choice that we may not give you this. We might give you this, right? So sometimes you can simplify those. Sunita?
Let's say there's a random response question. It would specifically say, like, write it in simplest form, right? And if it didn't, then the other one would be fine.
Correct. It does say in simplest form for the general solution, you would have this. But as I said, we will usually, most of the times, accept this. You have to realize that they're the same. Okay? There's some nice equations where you end up getting this from one set. So like say cos squared theta equals a half, and then you get here and here from say cos equals 1, and then those are all 60 degrees apart.
Maybe cos squared theta is equal to 1.
What? No. Here, if I had cos of theta equals 1/2, this would be the reference angle of 60.
Yeah.
So that would give you this, and this.
Yeah, so cos squared of theta would therefore be 1/4. If cos of theta is 1/4.
Oh, right, yeah, okay, cos squared. And then here, you maybe have cos equals 1 and -1, right? And then it's every 60 degrees. So that simplifies to one general statement. Girls, stop talking. Okay, so sometimes you can simplify a fair bit. So be aware of that. I'm not sure if many of these here do. In any case, I want to give you another one that's not on here. Or maybe this one does. Yeah, I think. Okay, so let's do this. So this is a different extra question. I think this is maybe one that you could simplify the general solution. The angle hasn't been stretched or translated, so it's kind of back to yesterday's. Okay, so theta element of reals means show the general solution. If it doesn't specify, there's no way to tell there if I want it in degrees or radians, so we would accept either. If there's a translation, then you can tell, right? If it's degrees or radians, then you have to. Sometimes we'll say theta element of the set of reals, theta solutions in radians or in degrees. So in this case, we have a choice. Biggest hint, do not divide by sine theta.
Yeah, because the issue is people divide by sine theta and then it's gone. We should use factor. The thing is still there.
These solutions that you divide by. And actually, this restriction you divide by.
Yeah. It's like you can get because like if it's equal to 0, you just keep dividing, you can get to this like 1 equals 0. It's like, uh-oh.
Oh, you know what? I wanted to do something a little bit different. Could it do this? Make it a cube. Sorry. Make it a cube.
Yeah. That makes me think.
Oh, I think I messed this up. Oh, no. Hold on just a second.
What is happening?
What is happening? Yeah, tell me messed this one up. I did this so fast. Okay. Make this a 4.
Oh, okay.
We're making a question as we go.
I guess we'll figure it out.
9, I think so. To get special angles. We'll do 9.
Oh, yeah, 4, yeah, that's right. I've got to change the 20. Yeah, we've never gotten to the non-special angle. I'm not going to go there.
You see the importance of when you're taking the square root of both sides, the plus or minus, right? Especially with trig, because you'll miss out on two solutions. You forget that. So, maybe I'll do this one first, left to right. So when is sine theta equal to 0? So remember, we're doing a general solution. So I always do at least one rotation, 360 degrees or 2 pi. So here theta is 0 at 0. I'll do it in radians, then pi, and 2 pi, etc. I just do that. I just do 3 dots. It keeps going in that same pattern. Okay. Then here, sine is positive first and second, negative third and fourth. Sine is root 3 over 2, has a reference angle of pi over 3, or 60 degrees. Okay, so this is pi over 3. So, pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. So overall, I've got this, 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 this. Nice. That's like the one I was talking about before.
Will you ever get something where it's like, is it possible to have a trigonometric equation where the solution is theta is the set of rules? Like, there can be theta only on like, is that possible?
You mean like every single real number is the solution?
Yeah. It always works.
That's an identity.
Okay, well, yeah, no, like, yeah, I guess so. So there is. Okay.
Okay, so here, so you might have your two separate statements. So I'm just going to do it in green because this is not what your simplified will be, but theta here is multiples of pi. Right? This one here is going to be, what's the fastest way? So you could go pi over 3. So this one here, just try it for a second. Pi over 3. If we're doing sine being positive, it would be pi over 3. And then you can do that one plus 2n pi, this one plus 2n pi. The negative, like that's a lot of statements, right? That's 4 for this, plus 1 is 5. Looking at these, you can see that this one plus 3 pi over 3, which is 5, gives you this. This plus pi gives you this. So this alone can simplify to that, okay? But then overall, the magic happens, and these together, all of those green, right, are just multiples of pi over 3. As one statement, okay? Do you need this sibling? No, you don't. Okay?
Makes it look good.
Yeah. Okay.
Definitely do not put regular brackets. That's not important.
Okay, and then last one. So I'm going to do this last one. Just be quiet, please. So here, just a translation, no stretches. It's already solved for cos. Cos is positive. So first and fourth. Cos is root 3 over 2. So reference angle of, we're dealing in degrees, so 30 degrees. Okay, so if you didn't look at the domain, you'd probably go like this. Okay, then you'd add 60, like that, and then you go, oh, okay, 390 doesn't fall into that. So then you go theta equals 90 degrees. Okay, is that it? No. How many am I missing? One. Okay, because remember, if I change this to be theta minus 60, then this will be less than 300. This will be greater than negative 60. And this angle here is negative 30. So back up here, I should add in negative 30. Doesn't have to be in numerical order, right? If you forget about it, just put it there. Then, oops, sorry, not there. I'll put it back in this negative 30. Okay. So then when I add 60 to that, I get positive 30. Then it's nice to have these in numerical order. Okay. So there's two answers. So this is a case where it's often with cos, because cos is positive in both the first and the fourth, or sine being, no, it won't be sine because it would be opposite sign. So it's usually cos there, just always to check for those values. Guys, at the back, the whole, you feel comfortable? Valeria.
Couldn't it also be 0 degrees? No.
Zero's on the axis there. Or 60, negative 60 would give you a cos of root 3 over 2. Okay, so that's where we're going to stop for today. All right, so there are some questions in the text.